So our topic for today is the forms of complex numbers. We have four forms. First is the rectangular form or the Cartesian form. The second one is the trigonometric form. The third one is the polar form. And the fourth one is the exponential form. When we talk about Cartesian form or the rectangular form, we are using the formula of Z equals A plus BI, where Z represents the complex number, A is the real number, and I is the imaginary number. For the trigonometric form, we use the right triangle analysis from trigonometry that the opposite side of the triangle is r cosine theta, and for the adjacent side, we have the r sine theta. Therefore, substituting the value of A and B from Z, we have now Z equals r cosine theta plus r I sine theta. Or we have now Z equals r, the parenthesis of cosine theta plus I sine theta. Or we have r cis theta. For the polar form, we have the Z equals r times angle theta. And for the exponential form, we have e to the I theta is equals to cosine theta plus I sine theta. We also call it the Euler's formula, or we have now the Z is equals to R e to the I theta. For our problem number 1, express negative 4 plus 3i in exponential form. So to solve it, so as you notice, negative 4 plus 3i is rectangular form. So, what is our R? R equals the square root of A square plus B square. Or we have the square root of negative 4 square plus 3 square. R now is 5. Now, for our theta, we have the arctan of B over A. So we have now the arctan of B is 3 over negative 4. Or we have 143.13 degrees. Or in radian, we have 2.5 radian. So what is now our final answer for our Z? So we have now negative 4 plus 3i equals R is 5. E to the 2.5i. This is now your answer. Problem 2, express negative 4 plus 3i in polar form. So we have our R. R equals 5. Our theta equals 143.13. So negative 4 plus 3i equals, what is our formula for the polar? It is R times angle theta. Or we have now 5 angle 143.13 degrees. Okay, let's start. For the complex definitions of sine and cosine, we have e to the I theta is equals to the cosine theta plus I sine theta. This is also called as the Euler's formula. So, if we recopy this formula here and take the negative z, the angle, we can say now that this one, cosine z plus I sine z, as you notice, instead of using theta from the Euler's formula, we use now z, then rearrange it here, we have now cosine z plus iz is equals to e to the iz. On the other hand, this one, where e to the I of the negative z is equals to the cosine of negative z plus I sine of the negative z, when you transpose this and using the sine, the negative sine of the angle, you have now the cosine z positive now, but you use negative I sine z equals e to the I of the negative z. Then you add. So you have now 2 cosine z is equals to this becomes 0, e to the iz plus e to the I to the negative z. Or you have now cosine z is equals to e to the iz plus e to the I to the negative z all over 2. This is now the other formula for the cosine with respect to the e. On the other hand, to derive the value of your sine with respect to e, you have to consider the same thing here, but you recopy this one, the first one. Then, instead of using the negative sign for the angle, you bring it outside for the cosine. So you have now negative cosine z plus I sine z equals negative e to the negative iz. Then you add, this becomes now 0. So you have now 2I sine z is equals to e to the iz minus e to the negative iz. Bring down 2 here, you have now sine z is equals to e to the iz minus e to the negative iz all over 2i. This is also now the other form of sine with respect to e. Remember also that e is equals to 2.71828.